fraud analytics for about 7 years now, and I've seen it grow. The amount of data, the capabilities, the types of analytics grow exponentially just in the short time that I've been doing it. And in recent months and in the last year, this concept for us of big data has been thrust to the forefront, and that's where we've been teaming with IBM to get our clients using it, to get ourselves using it as well, and really ahead of everything. By the time you guys get out of here, you guys enter the workforce, more people are going to know it, but you guys are still at that point where you can really lead the drive into the big data world.
My name is Srinivas Kopisetti, and I'm with IBM. And just a brief intro on how I came into IBM, a little background, been in the industry for the last 20 years, and doing a lot of different things. So recently I changed my career into sales, so that's when I ended with IBM last 3 years. Since that time, I've been engaged with all big data related projects, big data related activities. And I'm so excited to be here to talk about the big data technology that IBM has put into this space and the kind of innovation they're bringing into this space, right? So Doug is going to kind of tie the fraud analytics space into the technology that they are using that is from IBM. And we're going to try to take it together in this journey. Now, if this data is coming at you at a really high velocity, of course, large meaning you could put a size to it, right? It could be really large.
It could be the number of Facebook posts in 2 years. That's a lot of data. A lot. Across the world. Right? We believe that there's tons of volume of data.
Right.
Yeah.
So if you're getting this large sets of data at a high volume, and your CEO says there is a fraud going on in this data, this discussion that we are having today would help you. Okay, we have a way to deal with this velocity of data, variety of data that we are looking at, and also the volume of data. So remember, these 3 things actually make up that big data problem, right? You could just have velocity, or the amount of data that is coming to you is really fast, but you're not able to process that. That may not just constitute a big data problem, right? You could throw more infrastructure in place or more processing environments, you could get to that velocity levels, right? What if you have a lot of data coming at you at a high velocity, and on top of that, it is coming from your transactional systems and your social data and also your telemetry data, right? How do you really handle that kind of scenario in doing your fraud analytics? That's the kind of discussion we have today.
Yeah, so you guys haven't gotten into ACL too much, but that ACL does not have a write. It's one data set. It's your payables, it's your T&E, whatever that is. And it might have the volume, but it's a snapshot in time. You're going in there and you're looking at the data. You're looking historically, but you don't have emails in there. You don't have pictures in there. You don't have videos in there. You don't have social media feeds in there. So there's no variety. So it may have the volume, but it doesn't have the variety or the velocity. So that's the difference between something like ACL and big data. Whereas there's a lot you can do with it, but when you start wanting to do more and more and more and faster, that's big data.
Right, absolutely. So one of the big difference here about big data is traditionally, I don't know how many of you guys actually worked in information technologies or with a system that you use, right? Don't raise your hands, I'm fine with it. So what I'm looking for is it's an easy technology, right? So you don't need to have all those technical skills to really deal with it. With the toolings that we are providing on top of big data, our open source platform, there's a lot of tooling that IBM has put that will allow you to do those activities in a much simpler fashion, right? So that's about what I would leave it at, and then we'll
Yeah, one thing. So this it's technical. It's technical. It's technology. You don't have to have a computer science background to work with this stuff. I mean, I started every time I've come across computer science in my life, I've gotten a headache from it. I started the College of Engineering back in school. I took a computer science class. Immediately switched out because I couldn't handle it. When the first time that I had to work with SQL on one of my projects, 6-7 years ago, I was like, I can't do this. Like, I don't want to be part of this. But you know what? You need to know it to some extent now, and it's a lot easier than you think. I would say, like, the first time you open up an Excel file, and you're like, what does this do? How do you do this? Like, oh, this seems overwhelming. It's no different, It just can do more. That's the only thing. So yeah, it's a little bit more complex than that, but it can also do a heck of a lot more. But it can do all the things that you already know how to do in the other platforms. So don't worry, you don't have to be technical to know this stuff. Helps, maybe, but it's not something you can't pick up.
Yep, absolutely. Right. So, why actually this whole big data problem came into picture, right? People can use traditional systems. They were able to solve the problems that they had. Again, they were able to generate the reports that they were looking, in a very siloed fashion, right? You're only looking through what's inside the box, not really thinking outside the box, right? This platform gives you that capability to think outside the box, not to just look at the data belonging to, for example, just web applications or HR systems or finance, right? Now you have a way to combine all this data, find out all the data points within these data sets, and glean out meaningful information out of it. That's what this whole thing is about. And we're going to talk about the 5 use cases that we see mostly in the industry. I've been doing this for the last 4 years, and this is exactly what I would put as the major use cases that we encounter on a day-to-day basis, right? So big data exploration, right? So what this really means is, how can you use your existing data, not just looking at within the box, but looking at outside the box to make meaningful decisions? Okay? That's what that big data exploration is. There are a lot of tools around and techniques around that you can leverage to do those decision making, but this space is a very good use case for applying big data technologies, right?
So, in the fraud world, unfortunately, but typically back in the day, even when I first started, auditors would look at 10% of transactions and do a sample selection based on that to find potentially fraudulent activity. But now, we have the capabilities. There's so much information out there. Now we're talking about looking at everything. We're looking at everything. We're not limiting our scope. We're not limiting it based on time period. We're not limiting it based on region, anything like that. We're actually, with big data, you can explore completely everything that you have without any concern about the size of it, where it's coming from, what system it's on, anything like that.
Yeah. So that's an exploration area where we see. So another area where we see a lot of usage of this technology is, where you wanted to find out. I mean, I'm sure all these are MBA students, right? With some marketing knowledge, right? Yes.
Well, taking a marketing class.
Yeah. All right. I'm not trying to take a marketing class here, but
yeah.
But I just wanted to understand, how you really target your customers, right? You need to find out certain characteristics or some meaningful things that they exhibit that you can actually target those customers, right? So 360-degree view of a customer is another use case where we see big data technology is being used. Okay? What that means is, as a customer, you have done you've generated some data using transactional systems, meaning by interacting with a website, for example, Amazon, right? How many people actually buy stuff from Amazon? Yeah, thank God, I saw a lot of hands here. Right, so that's good. express positive sentiment and a negative sentiment on the other one, right? I can use that information to market you or your friends with the other brand that I wanted to sell, right? How am I going to do that? It's all when I put everything on a big data platform, look at all these data points, clean out all this information, and then tie it back to what I can sell you.
Yeah, it's like, you know, when you're on a web page or you're on your Gmail or whatever, and all of a sudden you see a banner advertisement for something. And it's not a black box. It's not, oh, people are watching us. Like, it's data going in that's being stored. Amazon storing all your data. They're storing all your web searches. Google storing all your data. They know your IP address. And it's all big data. It's huge, huge amounts of data coming in really fast, and they're targeting you. So you see, you buy a Movado and you buy a Rolex, and all of a sudden you get an advertisement from a watch repair shop.
Yeah.
And then that's big data. And that's one of the things it does.
Right. Context and based analytics, right? So another area is about security, intelligence, and extensions, and that's where most of these folks or the class is interested in, right?
Sure.
Fraud analytics, right?
Yeah.
So you wanted to add?
Yeah, we were talking about this earlier. Like, the way it started, you look at 10% transactions, you find some fraud, you kind of glean some information off that, and then it became looking at the full set of information, looking at a year's worth of data, and then finding fraud that happened 6 months ago, and it's like, okay, that's good, but what can we do about it? The event's already happened. It's already in the newspaper. Now we're getting with this big data when it's coming in live and huge amounts of it. We're trying to catch this stuff before the payments get made, before employees get reimbursed for paying off a government official or something. And that's where it's all headed, and without big data, there isn't a way to do that. A standalone data warehouse, the user needs to put that data in there. It can only go so far. It can only do it so quickly. And if we want to try to eliminate fraud and reduce fraud and really get down there, it's going to take big data.
So another area is operational analysis, right? So as you are doing transactions, right? Somebody stole your credit card and immediately trying to buy like 10 other things. Wouldn't it be very valuable to you to prevent those 10 transactions on the fly when that's happening, rather than 2 days later sending you an email, sending you a new credit card? Oh, you know what? Your card is stolen. Use this card, right? That would be really awful for businesses. So
there was one good example that I remember you guys showing us. It was about someone being lost at a hotel.
Mm-hmm.
You know what I'm talking about? Where they check where they monitor the swipes to find someone's key card from a hotel to find out where they are, and they use that in real life.
Yeah,
but that's like conceptually, that's like something like that's big data. It's coming in constantly. They're monitoring all the swipes, and they can isolate the person.
So in this scenario, basically you can use a bunch of technologies that are in the space. So one is you need to really apply your analytics as the data is coming to you, right? So real-time analytics is required, right? So I will talk about what kind of tooling is available to do that kind of stuff. Okay? And the other one is data warehouse augmentation, where this is about archiving your
exciting stuff.
Right, whole data. Yeah, exactly. So 10 years back, you did a transaction with Amazon. Nobody's querying that data. You know what? This is not required to stay in the warehouse. Let's move it off into Hadoop-based environment where you can query for later purposes, right? That's another use case that we see a lot. Okay. Right. So just wanted to go over a bit of an architecture. I know this is not computer science class, but I think this is required knowledge for you guys to at least walk through some of these scenarios once you go into the mainstream with other companies. Okay. So what we have on the left-hand side is all your various data sources. Okay. We talked about some of the streaming data here, right? Well, this streaming can be your music also, okay? But for whatever reason, if you are streaming some content, in fact, there's a very good use case that I'll briefly spend on 1 to 2 minutes. So back in start of last year, there's a lot of Olympics. Olympics were happening IBM was tasked to find out about how can we identify these streams, shut those guys down. We went about finding out who is streaming, right? There's a way you can actually go against the logs at the router level and also at the server level and identify the endpoints. So we did that. We went ahead and identified all those things. More than 110 websites were shut down, thereby keeping the revenue flowing for the big companies.
And us not being able to watch the World Cup.
So, so there is another text data example that I want to give you guys really quick. This is about a financial document, right? How many people actually looked at a financial report? Just raise your hands.
Everybody has it.
Yeah, exactly.
Better in this
right?
in this program.
Yeah,
If you got it this far.
Exactly. That's why I was trying to see all those hands up.
I try not to either. Don't worry.
Right.
Yeah.
So there are numbers in that, right? There is context in which that number is referenced, right? It's valuable information for people who want to sell the content, like your Bloombergs or Thomson Reuters or Yahoo's, who are trying to pretty much extract those numbers and use it for different purposes, right? You could use those numbers for your next purchase of the stocks too, right? So, in order to do this kind of text analytics, we have a platform within Big Insights, which is based off of a research project that came out. It was like 12 years or 13 years back, called as System D. We like to call everything as system within IBM. One is System D, which is your relational databases. Second one is System D, which is your text analytics. And System S is actually not the streams one. Oh yeah, I think System S is streaming system. Right? So just to give you background. So what I'm trying to get at is, if you have a document, you're trying to glean out some value out of that document, and you want to use it for other purposes. Imagine you're only talking one or two, it's okay, you can eyeball it and get it out. Think about you have a lot of documents, like 1 million of such documents, and you're trying to take out value out of those documents, right? What would you do? You would rather have an environment that can do it for you, right? Given intelligence how to do it, or given the filters, appropriate filters that you can apply on top of that, right? That's where the text analytics is coming in. This is about application data, and then we have time series, geospatial. So all the left-hand sides are your data sources, right? You're bringing them into this big data platform for running some analytics. Okay? So in the previous class, both of us were talking, that I asked a question: how many people actually know what is the difference between OLTP and OLAP?
Anybody?
I didn't.
That's fine. You don't need to. I'm just curious. Like, anybody had any idea about it? Okay. You might run into, tomorrow you join a company, you're dealing with your technology folks. They may say, oh, this is an OLTP system. This is an OLAP system. I don't want you guys to blank out on what they're talking about. Let me give a little background on OLAP and OLTP. Anything that you are doing transactionally, like purchasing an item from Amazon, is transactional. It's an online analytical, online transactional processing, OLTP. Okay? OLAP is online analytical processing, meaning you're actually trying to glean something out of a huge set of data that you have, a meaningful information out of that huge set of data. Okay? That's the difference. So this platform is about analysis. This is not about transactional systems. I just want you guys to understand that.
Yeah, you're never going to see housing payable. It's not SAP. You're not trying to house your payables here. You're not trying to. You're not going to build your P&E system into big data. That's just not how it works. It's an analysis.
Right. Okay. So there are certain capabilities here for this platform. You can get real-time analytics. You can load your data, for archival purposes. You can also have the direct connectivity into your warehouse environment, right? So the end goal is, you need to make decisions out of this data
fraud risks. I mean, any number of those things, and that's all what you get out of here. Report something to SEC.
So basically, this is all about information flow, right? Left is all your sources of information. Here, you're processing or doing something, and you're actually feeding that information to some other systems or a decision maker. Okay. So this is kind of complete information supply chain where you're looking at your source systems, you're taking some steps to process it, and then feed this information. Now, the big difference in the traditional way of processing data versus this is your data, you're basically moving your code more towards your data rather than bringing your data back where you want it to process. Okay, that's the key difference here. Okay? Right, so I just wanted to give a little perspective of what IBM's offerings are, what IBM has done in this market space, and basically we'll try to hit one or two points here on what you will be seeing a lot more in the future. Okay? So this is about the overall big data platform that IBM has. Right? This is all the analytical zone that we're talking about. Some of the risk analytics components are there as part of other software tooling that gets integrated into big data platform. So it doesn't inherently come as part of the big data platform. Okay? So this is the entire platform that comprises of your Hadoop system. This is your open source Hadoop software. We maintain the same open source distribution, and we actually test it, bundle it all together. We put another layer on top of that without disturbing the base open source. Okay? And add all our toolings and solutions on top of it. Okay? And then we have the streams computing platform here, which is again streams itself. The product name itself is called as Infosphere streams. That's what we use here. And then for data warehousing, we have a bunch of other appliances and software space. So, like we were talking earlier, we only talked about three things, right? Velocity, variety, and volume so far. Can somebody tell me the difference about veracity?
What is veracity?
Yes, come on. Nobody can
Take
be.
a guess.
Oh, sorry. Veracity is just how trustworthy the data is.
Absolutely. Yeah, absolutely.
And think about that from my perspective, and that's when we said in the other class. This is where Ian was. We need this for me. When you go to a client, you say, "Oh, we have this big data. We got taking in all your payables. We took in your emails from your company. We're doing all this." They're like, "Well, is this accurate? How do you guys know? You guys are doing so much. How do you know it's accurate?" That's why that fourth B is most important. You can't, especially if you're reporting to the government or it's litigation involved. It needs to be spot on, and you need to be able to prove it. It needs to hold up. It needs to be able to be replicated, and the analysis to do.
So, four major areas. I think we actually talked about all the 5 use cases here, but the 4 major pointers that actually determine that we have big data. We are applying all these 5 use cases on that. Basically for what, right? To improve your business, right? To improve your insights into the data, correct? That's what you're all trying to do this. In your fraud space, you're trying to find, like I like to use this analogy, like a needle in a big haystack. You have a huge set of data here, and you're really trying to find a needle out of that. You really need a lot more powerful environment.
The metal detector.
Yeah, metal detector. Oh, that's a good one.
This is your metal detector.
Yeah. All right. So again, I think we talked about these a little bit, but I just wanted to talk about what this Watson Explorer is, right? So remember where we had all the data sources on the left-hand side, right? Without processing any of the data, but if you were to have a tool that can go and index all the data and try to show you some basic information, right? example, for all the transactions that you have done on Amazon, as an individual, somebody wants to know what you did, what you purchased, what was your feedback, and how have you been doing in your future purchases, right? That also can be available as part of this tool. All it does is it goes to the data sources, indexes all the data, right? Stores a big index file. Think of it as a Google for an enterprise. What basically Google is doing is it's crawling all across, trying to create the indexes locally and point you to the resources. This is exactly what it does. But in a lot more please.
Is it related to the Jeopardy computer?
That is, that because of the name, yes, it is. So, Watson engine that was developed. A lot of intelligence that was built in that Watson technology, right? So what we did was, it's basically a cognitive computing environment, right? It learns as it understands the data. It parses it, it tries to reach out to a conclusion, and then, okay, what if tomorrow I run into a similar scenario? I can pretty much apply the same knowledge base that I acquired. Something like what we think, right, as humans. They try to give that brain into Watson. That's all part of that cognitive computing environment.
And Watson wins in Jeopardy all the time. It has a delay on Watson before the button. Like a person can press a button.
Yeah.
Watson has
Boom.
a built-in delay that IBM built in. So
Yeah.
Watson's at a disadvantage and still wins all the time.
Yep. There's a lot of accuracy for that data. I mean, it's amazing. So many researchers have put a lot of effort in putting that intelligence into that. It comprises of your text analytics, some of the statistical models. It scores, what is my accuracy level for this question, right? If it feels this is not accurate enough, it will try to go fetch other data sets. Okay. So the second one is Infosphere Big Insights, which is the Hadoop environment, right? What we did was we took that environment, as I mentioned, we put all our tooling on top of that, and then made it as a distribution for companies to adapt into.
Yes. Big Insights is what someone we log into, it's where we put our data. Sorry. I'll speak up. But that's basically, that's the end user gets. It's a user interface. It works pretty well. It's intuitive. So.
Yeah. If possible, real quick, I'll try to show that interface and take you through that trip. The third tool that I'm introducing to you guys this is again a platform, one of the component of our big data platform. This is called as Infosphere Streams, which does analytics on the fly, meaning once your data originated from the place, right? Before it lands onto your destination, you're applying analytics on top of that.
Yeah, so I would
Okay.
say this is, to me, and working in this field for a while now, that's where it's headed.
Yep.
Streams. That idea of live. To be able to go in and see things as they're happening, to stop things from going out. The value there is unbelievable.
Yep.
And we're trying as hard as we can as a firm to really get that involved and get our clients to buy into that, because it's not always the easiest thing to set up, but it's going to change the way.
And doesn't that eliminate then the security issues about the data? Because you said you're going to the transaction instead of bringing the transaction to you. So now you don't have to encrypt, all across the whole system. So is that right or not?
No, that's not 100%. No. So basically, as the transaction is evolving, right, it moves through the wire, right, to land it onto your second system or into your disk area.
Okay.
You can actually put this to intercept that data and apply analytics on top of that.
It's still moving
Still coming into your
into your space, yeah.
still coming into Big Insights.
Correct, yeah.
Very good.
Right. So any questions?
What are the challenges of setting up
Streams is pretty straightforward. There is absolutely, we have a software bundle. It's a package installer. You just install it. Typically, you can run it in one node or two nodes, or you can actually scale it horizontally. That's the beauty of this environment. The
purpose of the big data platform is to have an ability to scale it horizontally. If your needs go up in future, you still can live with the same systems, but scale it so you can process the data at the same rate, right?
It's all about what data you're getting too, right? Like, I mean, if you want to analyze Twitter feed data through streams,
Yeah.
I mean, it's not the easiest thing to get. You have to.
Yeah, you have to have a.
It's expensive.
Twitter data, you can buy it from third-party providers, actually. There's a provider called GNIP. GNIP or GNIP. So you just have to pay that subscription. Yeah. So we actually have a pre-built application. Again, when I mentioned the tooling, right, you guys really should see an open source version and what IBM has put in as far as the applications that they built within this environment. A lot of applications, trust me. If you were to develop these, it's going to take a lot of time and effort for companies to develop these kind of tools. We are just including it as part of the environment. Okay? If you guys are interested in downloading Big Insights, okay, go to this link. There is a virtual machine that we actually packaged everything in. It's a one-node machine. You can download it and play around with it. Load your files, run some analytics, like, for example, for the stuff that you will go through, the ACL labs or whatever it is. You can take those files, put it on that environment, and do the same kind of analytics in that space. Okay?
Yeah, I'm thinking about maybe we actually do this in a class and go through it to have a web-based big data application to look at. I'd like you to see this.
Yeah.
That's great.
I would like to get your help maybe setting that up.
Sure, yeah. So this is about the streams. Again, a little info. So we actually developed this for the government and law enforcement, and that was, made it as a product 5 years back, but this evolved right after 9/11, just for the government to track what is happening in the cyberspace, how all these terrorists are communicating, what do we do to prevent them, and all kind of stuff.
I think, what was a good example that I heard? I think it was a Dublin bus system.
Yes, they are piggybacking on the traffic.
Yeah, so when you go to a bus station and it says, there's 10 minutes till your bus gets here.
Mm-hmm.
It's like, well, who's telling the sign that it's 10 minutes till the bus gets here? Well, this is big data, this is streams and the work, right?
Yeah.
I mean, you have the GPS from the bus telling us where the bus is. You got traffic information coming in. The information from the stoplights and stop signs all feeding into the system and telling it it's going to be 10 minutes.
Right.
Maybe it'll change.
Yeah.
I say 10 minutes for a little while. It's constantly. That's big
Right.
data.
Yeah. So they did another project. You reminded me of mentioning about another project that they did in
I always find
Europe.
it
Yeah.
interesting
It's
because if you guys think like me, you sometimes take things for granted. You're like, oh, it's just think about it really. You're like, there's something that's doing this. There's computers and machines figuring this stuff out. It's not some operator calling, hey, the bus is 10 minutes away. It's all data. It's constant data now, especially now.
right. There's a project that was done in Europe called as connected cars. I don't know. I mean, this is real innovation that is happening. You will see this in like next 2 to 3 years coming up in the marketplace also.
What is that?
Connected cars.
Okay.
Yeah. So what the fundamental concept there is, of course, cars already has a lot of smarts built in, right? It's just a matter of tapping into those smarts and running analysis on top of that.
Yep.
What sensor is emitting what event at what point in time? What is the mileage that it had, and when is it failing? Wouldn't you be interested in knowing, one of the key component of my car is actually going to fail in next 10 days. Instead of you being on the highway, done, right? That kind of interesting, that's the interesting stuff that is happening right now, and a lot of car companies have adapted, and IBM has put that technology in place. The way they are actually analyzing all this stuff is with the big data platform that is there. Okay. Again, if you're interested in downloading streams, go to, I think this link is not showing up, but go to ibm.co/streams, and you can download. There is a virtual machine that you can use. And
So now you guys have seen all of what goes on behind the scenes, the data, the process, and the amount. But then it's how do I use this stuff? And that's where companies like E&Y come in and try to make it meaningful. And what we do is something like this. This program is Tableau. We're trying to start implementing more IBM programs like Cognos for our visualizations. But all this right here is sitting on top of that big data platform. So the user will see this, but they won't see all that's going on behind the scenes with what you were talking about, the map reduce and the optimizations and stuff that are going on. And what we give to our clients is these exact dashboards each, and every one of these things is a filter. So for like you're saying for auditing purposes, you'd have all your payables here. You'd have all your, I'm looking at T&E now. You have all your expenses sitting here, and it allows the auditors to filter around to try to isolate potentially fraudulent activity with massive amounts of data behind the scenes. And then you can do all this. You filter down. You say you want to see transactions only in Spain because you're interested in Spain. You could see I'm only looking at other expenses or meals, for instance. You only look at certain employees, certain business units. Again, there could be a lot more. But the big thing that we have here, which we get from the big data, is concepts. So we do text mining on, like, if you figure out, I don't know if anybody has entered an expense report before, and you say, it says purpose or reason for expense, and you fill it in. I went to dinner with, Rutgers University. What we do is we do two things, and one of them is not up here. We do concepts mainly, and which basically what it does is it reads your free text descriptions, and it comes up with what people are talking about. So people are talking about meals, people are talking about conferences, and then associates all those transactions based on those concepts that it finds. It mines the text, and doesn't just give you, everything everybody's saying. It actually gives you these common themes that are going on, and so you can limit your data in that way. Another thing that we do is we do entity extractions in text mining. So like what I was mentioning before is if there's high risk, like again, we use something called the Dow Jones watch list. It's about 3 million entities, individuals that are deemed risky for whatever reasons. Maybe they're involved in litigation or something. And we take the free text descriptions from expense reports, from payables. We extract those entities, those individuals in those companies, and we map it up against those watch lists. So we can actually flag transactions that we believe are involved with those third parties. And then once we take all this in, and let me go back for a second. So I don't have that slide in here anymore. So we develop, when we go out to a client, we meet with them, and we want to do T&E expense monitoring. We talk about what their risks are. We have over 1,000 pre-packaged scripts that we run, and we select our analytics. We say, we want duplicative payments. We want payments with risky third parties. We want reputational risk vendors. We want, potentially bribe keywords in the expense descriptions. And we build in all of those analytics, and for every transaction that we have, we flag those analytics. We flag it with a yes or a no. And what we do at the end is, and this we were talking about before about monitoring employees, we risk rank them. And that's a big thing. This is how you're using big data. And so what the user sees is comparative to their peer group, how employees have been hitting on these tests, how their transactions are hitting on these tests. So then they're not looking at everybody. You're not auditing everybody. You're not doing a 10% sample selection. You're actually looking, based on the metrics that you've defined using big data, you're finding the riskiest employees or transactions or vendors or payable accounts, whatever you want to break it down. And this is how we're using it. And this is what companies love, honestly. They see, you still have that, you have that old school mentality where you're only looking at a certain amount, but now what you're looking at is where the activity is. It greatly increases your likelihood of catching fraud or abuse or corruption, whatever you're thinking about. This is a transaction risk scoring, and what we do is, here you'll see all of our tests here. And this, one day maybe I'll send you an example that you can show. But you can change the weighting for tests, things you deem to be more relevant, more risky, and it all updates on the fly. I think that's all I want to say. Is there anything about big data? Now, this slide's important, and I know we talked about it before, but in our world, and what we're really pushing for is typically, and like ACL, that's structured data. That's transaction level payables data. It's T&E data. But what about emails, social media? What about interviews? What about if you took interview notes with somebody, or somebody was deposed and you have depositions? What big data allows you to do, it may not be large in size, but they're very, very different. And it allows you to take structured data. So, for instance, you have an expense with Doug Manhart's expenses. And you filter in our dashboards, and this is what we're developing, for Doug Manhart's expenses. And then you'll have another pane that then will show Doug Manhart's emails, Doug Manhart's Twitter feed. You'll see Doug Manhart's interviews that he was involved in, where his name was mentioned in an interview. And then you have the concepts involved in that. You say bribe, fraud, processing fee, anything like that, and you filter on that, and you can, get a quick, 15 minutes you could find really, really hot documents, hot transactions to help isolate fraud. This is not something, I even, when I first started, didn't even think about doing. And, it's unbelievable. And our clients couldn't be happier with it. And they, as a firm, we're kind of on the cutting edge, and I think it's just a matter of time before everybody's using this.
Quite a few people in this class will be working for you guys. So.
Come see me after. We'll talk about it. Yeah, that's really, I know we don't, here's just one thing I was saying. A big thing that we've faced in the past using SQL Server environments is processing time. This has nothing to do with the client, but I ran this study when we had IBM over at Secaucus when we were doing an implementation of big data, and the statistics are ridiculous, the comparison between the speed of big insights on big data. Don't forget,
So 3.6 million journal entries for high-risk terms took 3 hours under SQL.
Yep, sometimes.
2 minutes in.
Yep.
That's amazing.
So we also push the limits. So in SQL, let's say this was keyword search on 36,000. SQL might actually beat Big Insights on that, because Big Insights has to run stuff in the background that takes time. But once you start, we took something 130 million records, and they laughed at me at IBM when I said, that's big, 130 million records. They're like, no, that's not. It's not big. 1 minute and 4 seconds, and this one actually took just a little bit, twice as much. But, they could do anything and fast. And what we were talking about 8 core 6 data nodes. He was saying 3 was kind of the minimum. So this is not, we don't have a powerful one, or as powerful as you'd like to. That's it.
Anything else? Any
questions?
For Doug? Anything, both career type questions as well as technical or whatever? Anything you want to know about life in Ernst Young?
Yeah.
He's living the dream, right? Making
It's not bad.
$500,000 now?
A little more. No, it's great. It's great. But seriously, ask me questions, because I'm not that far removed from this process at all.